Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. If you've ever worked or looked at exponential models, you might have seen several different formats of the equations. You might have seen a of t equals a 1 plus r to the t. A of t equals a 1 plus r over n to the nt. And you might have seen a equals p 1 plus r over n to the nt. And then over here you might have seen, this one's going to be a little bit different. Okay. So the top one is just the second one where n equals 1. They've just simplified it. The third one down is really the exact same as the second one. They've just switched out an a to a p. And then over here, this one now has the p, but the r is in a different place and the t is in a different place. This one is only going to be used, and I'll talk about it later, if you see the word continuously. Okay? The other ones are the ones that we're going to use. Most of these assume that t is time in years. N is the number of times something happens each year. R is your annual, because year is annual, right? Annual percentage rate. And lowercase p or lowercase a, depends on which version you're looking at. I think this is the one that's on the Algebra 2 EOC formula sheet, is your principal or your starting amount. If you've taken personal finance, you might have heard principal, and now we're starting to think in financial terms, right? And that's normally where you see this equation in financial terms. So when we're talking about this, we do need to talk about the fact that this formula is for like a one-time deposit. This is not like a 401k where you're putting money in every month. This is more like a CD, which is a certificate of deposit, where you put your money in one time and then you just let it sit in there for several years to come. So let's say you have, maybe you were gifted on your 18th birthday from a great friend. So on your 18th birthday, you're gifted $3,000. But it is stuck in a certificate of deposit. They call it a CD, not the kind of CDs that we used to listen to and, in the 90s on the radio and to hear songs. However, the CD does not come to maturity until you reach 65 years of age. It does pay 2.5%. And that is going to be quarterly. Okay, so what does all that mean? Okay, it means our principal was $3,000 because that's how much we were given initially. Our annual rate, but we have to, anytime you go into formulas, you've got to get rid of the percent sign. So R is going to be 0.025. Quarterly means something's going to happen 4 times a year, so N is going to be 4. And if it starts on your 18th birthday and you can get the money out at 65 years, that means 47 years are going to go by between your 18th birthday and when you can actually get this money. Okay, so all we're going to do now is pop this into the formula. So your ending amount, your final amount, will equal 3,000, because that was your principal, 1 plus your rate divided by N to the N times T. Now I will warn you, depending on your calculator, you might want to go ahead and multiply that by hand first or put parentheses around it so you don't make a calculator error. Okay, so let's go ahead and type that in. You should be getting an answer in your calculator of $9,678.97. So the money basically tripled. Had you started with a bigger value, let's say had you started instead of with 3,000, let's say you had started with 30,000. Change that P to 30,000. Go back, type in 1 extra 0. Now you're sitting at 96,000. So your money still tripled. But because you started off with 10 times more, you ended with 10 times more. So the growth is going to be the same amount growth, whether you start with $1 or $30,000. It's just you're getting that compounding interest, and the more you have, the more it snowballs. Which is why my big push here is that as soon as you get a full-time job, you start putting money into your 401k so that it grows quicker. We will be talking about that here in a minute, but investing early allows the snowball effect to work in your advantage. Okay. Now, while money usually compounds like quarterly or weekly, or unfortunately when they do credit card interest, it goes against you daily. There is a formula for growth and decay that does not happen in intervals. The animal that's laying dead on the side of the road because it got hit by a car, it doesn't only decay every 4 hours. That decay is going on continuously. Your body doesn't just metabolize medicine like, oh, it's 6 o'clock, I better use some of that medicine. No, it uses that medicine continuously. So things that happen continuously we can't count the number of times that happens in a year, so we have no end value. So that's where this other equation comes in. Now, the number E, you can find it on your calculator. It's probably in the background of a button that looks like IN. That's really LN. E is approximately 2.71828. It's kind of like pi. They've used a letter to put in because the decimal, they don't want to write it all out. So anytime you say continuously, you're going to use this formula instead. So the word continuously means go to the E formula. So let's take your same $3,000 that we just talked about. Let's grow it continuously. We're still going to use the same percentage rate in the same amount of time. But now, instead of compounding quarterly, we're going to compound it as fast as the computer can compound it. So it's compounding all the time. It's adding in. So if you type that in, you're now going to get $9,714.43. So yes, it's about $35 more because it compounded continuously. But remember, if you multiply this by a factor of 10, then this is going to multiply by a factor of 10. So the more you put in, the more that additional compounding is going to make a difference. So let's compare some stuff here. And this is where it's really interesting, and I think it really plays a key. I know a lot of people say, This math stuff that you guys teach us in high school is never going to apply in the real world. Well, let's look at this. Option 1. I give you $10,000 at a 7% rate, compounded monthly, but you've got to wait 30 years. Okay? Or $30,000, still 7%, still monthly, 10 years. If you were to get the money today, let's say it matured today, the purple one matured today, the blue one matured today, which one's the better deal for you to get today? And I'm wording it that way because I had one student go, well, I would take this one because I would get more money and then I would just invest it myself. No, I'm saying, hey, which one would you want the balance of today? The purple one that's been accumulating for 30 years or the blue one that started off with 30,000 but has only been accumulating 10 years? So again, started with 10 but sat there for 30 years or started with 30 and sat there for 10 years? Which is the better deal? Okay, so that's where we're going to take that formula. These do not say continuously, they say monthly, so I have to use the longer formula. A equals 10,000. Monthly is 12 times a year, so 1 plus 0.07 over 12. Just this 0.07 is over 12. To the 12 times 30. If we type that in a calculator, remember parentheses around that power, you'll find out that this will have a balance of $81,164.97. Okay, do you want that one today? Or 30,000, 1 plus 7% monthly for 10 years. And again, remember parentheses around that exponent. If you type that into a calculator, so this one started off with a lot more money, but was only in there for 10 years. And look, it started off with 20,000 more, but now it's 20,000 less. I want you to keep this in mind when you start thinking about that retirement, because if you wait until, if you let, let's say you start in your 40s planning for retirement, you miss out on 20 years of compounding interest. You're going to have to do more than triple the amount to make up for it in your retirement account. Because look at the imbalance here. Like this one started off lower, but look, it's already up higher. So please keep that in mind, that making this compounding interest work for you when you start saving for your 401k. Don't think of it as giving away money. You're not. Let's say you get a financial advisor. You're not giving them money. You're putting money into a special savings account so you don't spend it on Starbucks or extra coffees or Dunkin' or wherever your favorite coffee place is. Now, on the flip side, when you're borrowing money, you need to have the shorter years so that the bank doesn't benefit from your borrowing money, because that's what's happening is they're making it the better deal for them. So when you borrow money super short term so that you pay less interest, when you're investing money super long term so you're snowballing your investment. So that's a really key point to pay attention to with these formulas. And if you have questions about how a formula works whenever you have a monthly payment instead of a one-time payment, go ahead and let me know and I can add to this video. But really, this is just making sure you understand that interest rates compound, and the more compounding you can have, or the more times they give you interest, is it better to have it every other week instead of monthly? Sure, it'll grow just a smidge more over time. But it's more important that you get that longevity in there than anything. So make interest work for you.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.